starting the unique custom motorcycle build project. The mechanical expert selects a pair of wheels with aluminum alloy rims, painted in sporty black and orange. The hub hole dimensions of the rim are measured accurately using a digital caliper. A round steel plate is chosen as the center flange. He uses a marker to mark the hole positions. A steel drill bit pierces through the metal workpiece. A hole saw hollows out the center of the flange, allowing the cylindrical steel tube to fit through. This axle core will bear the main load. Next, an old brake disc is placed on the drill press to machine. Holes matching the flange. The part is clamped tightly in a large mechanical vise. A low-speed hand drill, fitted with a tap bit, is used to create internal threads. This technique ensures proper bolt penetration, creating a durable mechanical connection. He moves on to machining the frame. A solid square steel bar is carefully measured, using a tri-square and a marker to perfectly divide the distances. The steel bar is brought to a high-powered drill press. Metal shavings fly out as the drill cuts deep to make a peg hole. Returning to the flange, 4 tiny U-shaped clamps are temporarily mounted. The center drilling positions are carefully marked before machining. Metal cutting fluid might be needed, but he drills it dry very decisively. Clamping the flange in the vise, the thread tapping process is meticulously repeated. The tap bit cuts into the metal, creating precise spirals for the anai hex bolts. Using a wrench, the 4 U-clamps are bolted securely to the steel flange. This will be the clamping mechanism to hold the rotating axle. The steel tube axle is threaded through. Marks are made through the clamps' drilled holes to determine the bolting points on the tube body. The cylindrical steel tube is clamped tightly, and the drill bores deep into its round wall. Drilling a hole on a curved surface is prone to slipping, requiring absolute control. Once again, it's the tapping step, creating internal threads that align with the clamp. He carefully presses 2 load-bearing industrial bearings into both open ends of the axle. These 2 bearings eliminate rotational friction, helping the hub operate smoothly. He finishes the center hub using thick threaded rods, bolted through the flange structure, and the clamp mechanism to secure the axle. The technician tightens the hex socket bolts, securing the ventilated steel brake disc to the other hub, using a high-speed cordless drill. Similarly, the drive sprocket is accurately mounted and fastened with Phillips screws. The 2 custom-built hubs are complete, ready to integrate with the brake and drive systems. Placing the tire on a U-shaped wooden stand, he gently drops the hub into the center of the alloy rim. Using a wrench, he sequentially tightens the nuts, securing the flange to the rim spokes. A tape measure is pulled out to check the size. The measured tire diameter is about 45 centimeters. From his collection of suspension forks, he astutely picks out a sleek silver pair of front forks. Marking a short section of steel pipe, he mounts it on the drill press and pierces the metal to create a peg hole. Clamping the workpiece in the vise, the tap bit is used again to cut internal threads into the steel pipe wall. He attaches a pair of L-brackets to the steel pipe, then slides this assembly onto the top of the silver forks. Moving on to a flat steel plate, he uses a tri-square and a marker to sketch a basic isosceles trapezoid. He marks and sequentially drills multiple holes on the steel plate. to prepare the load-bearing connection points. The thread tapping process is repeated, turning smooth holes into dedicated mounting points for a secure fit. Blinding sparks fly as the angle grinder cuts the steel plate to the exact trapezoid profile. This is the custom triple tree. The fork holding tubes are mounted to the steel plate using hex socket bolts. Taking a solid cylindrical steel bar, he drills a deep hole right in the center to serve as the steering stem. Tapping threads into the newly drilled hole, he then screws a thick threaded steel rod into the stem to create connecting brackets. Thread the axle into a larger steel tube with pre-pressed bearings, completing the triple tree shaft. Use a heavy-duty manual bender to curve the round steel bar into a wavy U shape to make the handlebars. Drill holes in the handlebars. Install the butterfly clamp mechanism and connect it to the steering stem assembly. Just completed. Attach this entire handlebar assembly to the trapezoidal steel triple tree. Using tightly secured bolts, place the front wheel rim between the two forks, tightening the wheel axle nut through the hub to secure the front wheel. Finally, slide the forks up into the custom triple tree and tighten the lock nuts to secure the suspension system. The copper gold front disc brake assembly is carefully mounted onto the fork. Tighten the bracket holding nuts. The horizontal cylinder internal combustion engine is placed on the table. Measure the dimensions using a tri-square. Sketch the engine mount on a thick steel plate. Draw lines to mark the cutting boundaries. The steel plate is put into the drill press, piercing each hole, preparing the metal for the bolting points. A handheld angle grinder is used to cut off the excess steel, creating a flat and perfectly square engine mount. A flat steel bar is measured and marked, placed into a manual bender and bent to form a foot peg bar. Drill holes and use hex screws to secure the U-shaped foot peg bar firmly to the bottom of the mount. Slide anti-slip rubber foot pegs onto both ends. The engine block is placed to fit perfectly on the mount. Flip the engine assembly upside down and use a wrench to tighten the engine mount bolts. Roughly arrange the component assemblies. To start building the main frame, use a custom compass to draw two concentric circles on a large sheet of metal. With masterful cutting and grinding skills, guide the cutting blade along the curve to create a giant metal ring. Use a protractor and compass to mark evenly spaced points. This is the unique circular main frame. Place the steel ring on the drill press and accurately drill connecting holes through the flat surface of the ring. Press the two steel rings against both sides of the engine mount and tighten the bolts to form the body structure. Pull out a tape measure to check the distance for connecting the steering neck. Mark and cut trapezoidal connecting steel pieces on the workpiece. The angle grinder with a cutting disc cleanly shapes the metal into two thick, load-bearing triangular flanges. Drill mounting holes and bore a large hole to reduce weight and create a mechanical highlight. Another flat steel bar is bent into a perpendicular U shape, drilled and tapped to serve as the steering neck connector. Clamp the triangular steel flanges to the U-bracket using locking pliers. Drill center holes and install bolts. Connect the steering neck assembly to the circular frame. Tighten the hex bolts to firmly connect the two modules. Stand the front fork up to connect the chassis with the swing arm. The steering system basically takes shape. Measure the wheelbase distance. Take a thick steel plate workpiece and use a square to mark the profile of the rear swing arm. Place the workpiece on the magnetic drill press and use an alloy hole saw to cut out 2 large round holes to help reduce weight. The angle grinder makes parallel cuts to hollow out the groove between the 2 holes, creating an aerodynamic design. By smoothing the cut edges with a grinding disc, we get a pair of rear swing arms, with very sporty ring-shaped force-dissipating grooves. Attach a load-bearing U-bracket, drill precise holes, and tap threads to install high-strength hex screws. Mount the steel swing arm pair onto the pivot position on the circular frame, and tighten the nuts, forming the rear suspension system. The rear wheel axle is threaded through the swing arm slot, and an industrial drive chain is draped over the sprockets to adjust the chain slack. The rear disc brake caliper assembly is securely fastened. I proceed to make a uniquely styled leather-wrapped seat. Cut and bend flat steel bars to make the seat base. Use a hydraulic angle bender to create a bent profile. Use a screw gun to fasten the steel strips tightly to the plastic base of the seat, ensuring proper adhesion and load-bearing capacity. Weld the subframe using square steel tubing, and bolt the seat mount onto the circular structure. Install the Maroka single-coil rear shock to connect the rear swing arm and the mounts, completing the monoshock suspension. Screw the leather seat securely in place and conduct a static load test. The suspension travel works smoothly and softly. The disassembled frame has been powder-coated in red and yellow. Install the switch assembly and hydraulic brake lever assembly. Tighten the brake fluid reservoir screw, open the cap, and pour in brake fluid, bleeding the system to remove air bubbles. Turning the wrench to fine-tune the throttle cable tension at the carburetor, optimizing the throttle response for the engine. The bronze front brake caliper is accurately mounted. The technician adds hydraulic fluid, continuously squeezing and releasing the brake lever to bleed air bubbles from the system. A 10Ah battery is placed into the magnetic compartment. A wrench is used to tighten the copper electrical terminals. A red powder-coated U-shaped steel bar is bolted across to support the fuel tank. The bright yellow plastic fuel tank is placed on top, connecting the fuel lines to the carburetor, and fuel is added. The matte black exhaust system is bolted to the engine. A side stand with a return spring is also attached. The kickstarter lever is installed onto the shaft. The chain tensioner with a plastic roller is securely bolted to the V-shaped swing arm. The rear mudguard, made of composite material, is curved and bolted to the shock absorber mount. And securing the front forks with a red tie rod. The CDI ignition wiring connections are completely hooked up. Turning the ignition key. Forcefully kicking the starter lever, the engine roars to life. The drive sprocket turns the rear wheel rapidly. Proceeding with a practical test drive. The machine, with its circular frame, glides powerfully on the asphalt. The unique geometric structure provides a low, balanced center of gravity. The fat tires and forks absorb impacts perfectly,